All right, let's talk about nutrients. As I mentioned earlier at the beginning of this chapter, we have six nutrients, but you might see like the term optimal nutrition. So when we say optimal nutrition, it means any type of nutrition plan or eating pattern that prevents nutrient deficiencies and also prevents chronic diseases. And chronic diseases means like the disease can that can occur during the period of time, like diabetes, different types of cancers, heart disease. And as I mentioned, we have six different types of nutrients: carbohydrates, proteins, fats, vitamins, minerals, and water. We also have electrolytes that are very important in sport. And the definition of electrolytes is the any substance in a solution that conducts an electrical current, like sodium and potassium or chloride. These are all considered electrolytes in the body. So and these are very crucial in exercise and physical activity. And also we have fiber, which is a food component that resists digestion. And so here, the terms you have to memorize and remember is the definition of electrolytes. And when we say like an athlete needs optimal nutrition, it means it should prevent nutrient deficiencies and prevents chronic diseases. We have dietary reference intakes or DRI, which is a standard used to assess nutrient intake and plan diets for healthy individuals and groups. It also guard against both nutrient inadequacies and excesses. So it's like kind of like saying whether we have an optimal nutrition or not. And DRI has four subgroups. We have RDA, recommended dietary allowances. We have adequate intake or AI. We have EAR, estimated average requirement, and tolerable upper intake level. And let me define these here and the differences between these terms. So RDA, recommended dietary allowances, is the average daily dietary intake that is sufficient to meet the nutrient requirements of about 97 to 98% of healthy individuals based on stage of life and gender. So RDA has a table and it is categorized based on gender and stage of life. And the values showing that, for example, let's say RDA for vitamin A is just saying like 20 microgram. So this 20 microgram means if it's the average daily dietary intake of vitamin A, which is sufficient to meet the nutrient requirements of almost all of the healthy individuals in the population. What's AI or adequate intake? We use AI when we cannot determine RDA. When we cannot determine recommended dietary allowance for a nutrient, we use adequate intake. And it is a recommended intake value based on observed or experimentally determined approximations or estimates of nutrient intake by a group of healthy people that are assumed to be adequate. And the EAR, it's very similar to RDA, but there is only a slight difference. So RDA shows the average dietary intake, which is sufficient to meet the nutrient requirements of almost all of the healthy population. But the EAR is the half of the healthy individuals. So EAR shows the amount of dietary nutrient intake that can meet the requirements of 50% of the healthy individuals in the population. And that's the only difference between EAR and RDA. And about the tolerable upper intake level or UL, it is the highest daily nutrient intake that is likely to pose no risk of adverse health effects for almost all individuals in the general population. Uh, in addition to dietary reference intakes, we have the physical activity guidelines. First, it was issued in 2008 by the US Department of Health and Human Services, but it was updated in 2018. And we have the physical activity guidelines for children and adolescents and also for adults. So for children aged between 6 and 17, this guideline recommend 60 or over 60 minutes of moderate to vigorous physical activity daily. And mainly it should be aerobic, like the cardiovascular fitness exercise time. And also, it recommends vigorous intensity activity, muscle strengthening, and bone strengthening for at least 3 days a week for children and adolescents. Regarding adults, these guidelines recommend 150 to 300 minutes of moderate physical activity per week, or 75 to 150 minutes of vigorous intensity aerobic per week. Also, it includes muscle strengthening activities or greater intensity activities on 2 or more days a week. And we have the dietary guidelines for Americans that I mentioned here, the DRI. In every 5 years, the dietary guidelines for Americans gets updated. And it is by the US Department of Health and Human Services and the US Department of Agriculture. So in every 5 years, the US Department of Health and Human Services and the US Department of Agriculture, they work together to publish the dietary guidelines for Americans. These guidelines, remember this, provide dietary and also exercise advice to Americans over the age of 2. What's the goal of these guidelines? To promote health and reducing the risk for chronic diseases. That's the ultimate goal of the dietary guidelines for Americans. And here we have some examples that I extracted from these guidelines. For example, it suggests limiting added sugars to less than 10% of calories per day, starting at age 2, or limiting saturated fat to less than 10% of calories per day, starting at age 2. Sodium should be less than 2,300 milligram per day for adults and even less for children less than 14 years old. Regarding the alcohol, it should be 2 or less drinks in men and less than 1 or less drinks in women. Let's answer this question. You can pause the video and answer on your own, and then you can resume the video. Let's answer this. Which of the following is true regarding dietary reference intakes or DRI? Option A. Adequate intake is used only for vitamins and not minerals. Option B. RDA, recommended daily allowances, represents the daily intake sufficient for nearly all healthy individuals. Option C. Estimated or EAR or estimated average requirement is intended to meet the needs of 100% of the population. And the tolerable upper intake level, or UL, is the minimum amount required for health. And as you can say, the option B is the correct one. EAR is intended to meet the needs of 50% of the population for option C. And AI can be used for vitamins and minerals both. And UL is not the minimum, it's the maximum amount required for health. Um, let's answer this question really quickly. Again, you can pause the video and answer on your own, and then you can resume watching the rest of the video. According to the 2018 physical activity guidelines, how much moderate intensity aerobic activity should adults engage in per week? Option A, 30 minutes per day or for 3 days per week. Option B, 100 minutes total. Option C, 150 to 300 minutes. And option D, 400 to 500 minutes. Yes, option C, 150 to 300 minutes per week. There are a couple of meal planning tools that can guide like the general population as well as athletes in order for them to follow the dietary guidelines for Americans. One of the main, the most important actually tool is MyPlate. We have Food Pyramid and we have Food List System. We also have other tools like carbohydrate counting. Carbohydrate counting, it's important for people with type 2 diabetes or diabetes in general. And most people, like the general population, they do not use carbohydrate counting a lot. And the food list system, it's not very common these days, and most people, especially like health professionals, they use MyPlate. And the food pyramid, it's just for athletes. So these are the tools. These four tools are the tools and the means that we can use to follow the dietary guidelines for Americans. Regarding the food list system or exchange lists, it was formerly called exchange lists. For example, in the food list system, one small banana and one small orange, they can be used interchangeably, like because they have both 15 gram of carbohydrates and 60 calories. Food list system is based on macronutrient content. It doesn't care about the micronutrient content of these. For example, a small orange has high amount of vitamin C, and small banana has high amount of, for example, potassium. But in terms of the macronutrient content, they can use as an exchange in the food list system. And here we have MyPlate. As you are familiar with the MyPlate, it has four, or we can say five main sections. We have fruits group, vegetables group, grains and protein and dairy. And it's like a healthy eating routine. It promotes a healthy eating routine. And the main thing about the MyPlate is this. We don't have to follow the my plate for in each meal or each day. I don't have to eat like half of my plate should be fruits or vegetables in each meal or each day. But for like over a couple of days or a week, it's better to follow the my plate guideline. And the food pyramid, as I said, it's for athletes and it's validated for athletes 20 to 35 years old, weighing 50 to 85 kilogram, who train 5 to 28 hours per week. And let's talk about the nutrition facts label. As you can see from the the left side of the slide, we have an example of nutrition facts label. This is the label you see often, more often on the food packages or any drinks. It's used in the food market. The information we get from nutrition facts labels are calories, the number of serving size, number of servings per container, total fat, saturated fat, trans fat, total carbohydrate, dietary fiber, added sugars, protein, and as well as some micronutrients, including vitamin D, calcium, iron, and potassium. The most important part of the nutrition facts label is the percentage daily value, which shows how much a nutrient in a serving of food contributes to a daily diet. And the daily diet is 2000 kilocalorie. So, for example, here in this nutrition facts label, we have total fat 8 gram or 10%. This means this 8 gram in consuming just one serving of this product. What product is this? It doesn't matter. One consuming just one serving size of this product, it gives 10% of the daily diet, which is 2000 kilocalorie. This is all about the percentage daily value. And we have for vitamin D, calcium, iron, and potassium as well. So let's do some practices here. Here says an athlete consumes 1 and 1/3 cup of a food with his nutrition label. Let's calculate the following amounts for a 1 and 1/3 cup serving. So, for example, for calories. So, as you can see, 2/3 cup contains 230 calories. So, if we want to calculate the calories for 1 and 1/3 cup serving, we have to do some math here. But the answer we get from the math, it should be 460 kilocalories. Servings remaining, it should be 6 servings. So this is 8 servings per container. If we consume this amount of cup, we will get 6 servings. Total fat is 8 for this. We will get it's like double it. Total fat is 8 for 2/3. And if we consume 1 and 1/3 cup, we have to double it. It should be 16 grams. And for calories, the same. Let's see. We have protein. Protein is 3 gram. If we double it, it should be 6 gram. And percent daily value of fiber. Fiber is 14%. If we double it, should be 28%. And the added sugar is 10 gram of added sugars. And if we double it, we will get 20%. And these are the answers for our knowledge check activity. Let's answer this question. What does the percent daily value on a nutrition facts label indicate? Option A, the amount of food that must be consumed per day. Option B, the percentage of a nutrient in one serving based on a 2000 calorie diet. Option C, the portion size recommended for athletes. And option D, the RDA for the entire population. Yes, option B is the correct answer. We have some basic sports nutrition guidelines. So the dietary guidelines for Americans is a good starting point for both strength and endurance athletes. So any type of athlete can adopt the dietary guidelines for Americans and follow that as a good starting point. But they must be modified according to the athlete's sport. For example, for sprinters who run 100-meter or 200-meter have no need for food or fluid during their competitive event. Sprinters need a moderate amount of carbohydrate daily. So for the sprinters, they can just follow the dietary guidelines for Americans. But for marathon runners, they need food and fluid during the competition. So they have to modify the dietary guidelines for Americans. And here we have the basic sports nutrition guidelines. For energy, we need adequate amount of energy to support training, recovery, and performance, and to maintain good health. We can adjust the energy we get from food for weight loss. Regarding carbohydrates, this is the recommended carbohydrates for athletes, 3 to 10 gram per kilogram of body weight. And this, as you can see, this is a wide range, 3 to 10 gram. Why is this wide? It's because it varies largely by sport. And also timing of carbohydrate, it's very important. And we have proteins. Regarding the proteins, we recommend 1.2 to 2 gram per kilogram of body weight for proteins. And they should assumes like this amount of protein assumes that we have adequate energy intake. Again, the timing of protein consumption is very important. For the energy, for carbohydrate, for protein, and for fat, we are going to discuss these in detail in the subsequent chapters. But here is like an overview of the main, like the basics and the foundations of sport nutrition. So don't worry about this. Like when we say timing of protein consumption is very important in athletes, we will dive into detail about this later. And regarding the fat, they recommend 20 to 35% of total calories. And when the total fat is less than 20%, we have low fat effects, like some effects that can have on weight loss, preventing some chronic diseases, so on and so forth. These were the energy and macronutrients, and also we have vitamins and minerals. Vitamins and minerals can be met through diet if foods and nutrient dense and adequate energy is consumed. So for the athletes, independence of type of the sport or exercise they are performing, if they get adequate amount of energy daily, they would get enough vitamins and minerals, the sufficient amount of vitamins and minerals. Sometimes supplements also need, but most of the time they don't need supplementation for vitamins and minerals. And regarding the fluid, uh, there are several factors that impact fluid loss, like people who engage in physical activity, they sweat a lot because of the increase in temperature of the body, the humidity and the altitude of the environment and the outside. Like if they are performing some exercise or sport when the humidity is high, it can cause more fluid loss. So the fluid management and the being hydration is very important for athletes. Uh, they can loss of 2 or 3% of body mass during exercise. And we have hyponatremia, which means low blood sodium levels, and they can cause very serious problems and consequences for athletes. And the timing of fluid intake is very important again. It should be before, during, and after exercise and competition. So fluid athletes should get fluid before, during, and after exercise and competition, regardless of the type of exercise. And let's talk about dietary supplements here. We have a term here. Any external influence that may enhance training, recovery, or performance is called ergogenic aids. And these aids can be categorized into four main groups. They can be mechanical aids, nutritional aids, or dietary supplements. They can be pharmaceutical or psychological. And let's define dietary supplement here. The Dietary Supplement Health and Education Act passed in 1994 and it defined dietary supplement. Any vitamin, any mineral, herb, botanical, amino acid, metabolite, constituent, extract, or a combination of any of these ingredients are called dietary supplement. And there are some rules and regulations for producing and marketing dietary supplements. And let's have a quick overview of these rules and laws in this slide. DSHEA, or the Dietary Supplement Health and Education Act, provides labeling guidelines, such as the requirements for the supplement facts label. And also, it's very important to remember this DSHEA does not ensure safety and effectiveness of dietary supplement. FDA does not either have the authority to require that a dietary supplement be approved for safety before it is marked. However, in 2007, quality standards were mandated by the FDA. So the dietary supplements contain the intended ingredients. They should free from contamination and should be accurately labeled. That's the FDA guidelines for dietary supplement. And also we have good manufacturing practices, which is intended to bring dietary supplement manufacturing standard consistent with the pharmaceutical standards. 10 to 15% of supplements may contain prohibited substances. That's a lot. That's a huge number, I guess. 10 to 15% of supplements. So it's very, very important to be cautious when if you wanna take dietary supplements. You have to be very cautious about that. Overall, dietary supplements can be divided into three main categories. So, dietary supplement falls under the term ergogenic aids. And the ergogenic aids has four categories. Dietary supplement is one of them. And dietary supplement also can be categorized into three groups. Vitamins, minerals, amino acids in one group, botanicals, and herbals, other groups. Vitamins are the most frequently used supplement. That's very obvious for like by the general population and by the athletes. And let's talk about the botanicals. Botanicals, it's a compounds extracted from foods and then concentrated into liquid or solid supplements. These are all botanicals. And there are some examples for botanicals like garlic and soy supplements. They are all extracted from foods and then concentrated. However, the herbals, herbals and botanicals can be used interchangeably, but there are slight differences between these two groups. And the majority of athletes do not distinguish between botanicals and herbals. Herbals do not contain nutrients. However, botanicals contain nutrients. For example, soy supplement or garlic supplement, they contain nutrients, but herbals do not contain nutrients. They can use as alternative medications. 10% or less are used by the athletes are herbal. So dietary supplements like herbals, the survey shows that all, just maybe 10% or less athletes use herbals. And we have some examples here also for the herbals like ginseng, Joneswort, and other herbals. There are some programs that evaluate a dietary supplement. We mentioned that DSHEA and FDA doesn't have the authority to examine the safety and effectiveness of dietary supplement. But the dietary supplement industry, most of the time, they require an independent testing organization to govern their products in order to get the license to say we are safe and like in the market, and they can compete with other dietary supplement markets. These are the information. There are a couple of uh, information required by athletes before taking any supplement. Any athlete should ask these questions before buying or purchasing a dietary supplement. They should ask about legality, safety, purity, and effectiveness. Safety means the ingredients and the dose are in the safe zone. And the purity means there is no contamination and accurate labeling. These are all purity. And we have, as I said, we have independent testing organizations that evaluate a dietary supplement. And these are the main ones: NSF, Informed Choice, and USP. If you see these labels on a dietary supplement, you can trust that. You can trust that product. And let's answer this question. Please pause the video, answer on your own, and then resume the video. But I'm going to answer this. What's the primary goal of the SHEA in relation to dietary supplement? To ensure that supplements are proven effective before sales, to ban harmful supplements, to define dietary supplements and establish labeling guidelines, to require FDA approval of all supplements. Yes, the option C is the correct answer. And let's talk about the research design and methodology regarding sports nutrition. These research design terms are broad, so they can use in both nutrition, exercise physiology, or other fields. We have three types of research studies. Studies can be divided into three main groups. They can be case studies, epidemiological studies, or experimental studies. And also, we have different research design and methods. They can be control or experimental groups. We have randomization, placebo, double blind, and crossover design. These are different types of designs, research designs. Here we have an example for a crossover design. We have subject selection here. We have pretest for strengths, for example, and then we have random assignments. So people here, the subjects here, we have, for example, 100 subjects here. 50, 50 of them receive supplement X and 50 receive placebo. And then we have post-test for strengths, and we have post-test for strengths for both groups, and we compare the results. Then we have crossover, which means the individuals who get supplement X at the beginning, they should get placebo next. And again, we examine the post-test for strengths and compare the post-test for strengths between these two groups. That's called crossover. It's like changing the people in supplement X to placebo and changing the people in placebo first to supplement X. So everyone in this study design receive both placebo and the supplement X. There are some key concepts to avoid misinterpretation of scientific studies. Causation is not correlation. So when we say there is an association or there is a correlation between two variables, it doesn't necessarily mean that, for example, variable A causes variable B or vice versa. So causation is totally different than correlation. And we should be, if we study the correlation or association, we cannot interpret our results as causation. And the importance of replication, any type of study should be replicated. Like other investigators, other researchers should be able to repeat our study. And also we have extrapolation of results or uh, like the results should be generalized to other population or the entire population. And we should have accuracy of data interpretation, cumulative results and consensus, slow evolution and strengths of the scientific process, and usage of results in promotions and marketing. And these are the key concepts that like they are used to avoid misinterpretation. In the sports nutrition and in exercise science, we have credentials and certifications. There are a couple of different practitioners. We have clinical exercise physiologists, group exercise instructors, personal trainers, and there are some regulations and certifications in exercise science. And we have, again, credentials and certifications in nutrition. We have registered dietitian or nutritionist RD or RDN, which is a national certification and a licensure. We have nutritionist, it's a general term varying academic training. And we have other types of nutrition related certifications like CSSD is the main one in the field of sports nutrition. So whenever you see CSSD as a credentials, it's the like board certified specialist in sports dietetics. So people with CSSD, they are able to provide like dietary plans and like dietary guidelines or like any other types of like exercise plan or program to athletes. And finally, this is our last question. Let's answer this together. Which of the following statements accurately distinguishes correlation from causations? A. Correlation proves that one variable causes another. B. Correlation always involves randomization. C. Correlation and causation are the same in experimental designs. D. Correlation shows a relationship but not a cause and effect link or association. So the option D is the correct one. And here I provided some additional resources and sources for you, like NIH and the physical activity guidelines and supplement. Uh, let me say this here. Any type of website link that has org or organization or gov government, these are reliable sources on the internet. You can rely on and we can trust those information extracting from these sources.